Section 8.3, Cylinders and Quadric Surfaces. In this section, we'll study how to sketch and visualize surfaces given their equations. For multiple integrals and real-world applications, understanding the domain of a 3D object is quite important. Let's see this definition. A cylinder is a surface that consists of all lines that are parallel to a given line and pass through a given plane curve. The cylinder is generally defined if you collect all parallel lines, start from each point on a given plane curve, then that is a cylinder. Sketch z equal x squared in R3 in 3D coordinates. X and y, and here that is z, and z equal x squared will make a parabola on the xz plane, like that. Now, this equation is independent of y. So for all y, it is the same equation, which means that for each y, right now, this graph is for y equals 0. And if you consider for every y the graph, then the curve will be made again for each y like that. So here, if you try to finish the shape, then it is given in this range. Each cross section is a parabola, but in y direction, it's a cylinder. Okay. How about this one? Sketch x squared plus y squared equals 1 in 3 dimensions. If you try to make it in 2-dimensional space, then it is simply a circle. But if you consider a surface in 3D, then it'll be a cylinder. Okay. Now again, here 3D coordinates x, y, and there is z direction. And this equation makes a circle of radius 1 in the flat plane. So we have a circle of radius 1 here. So radius 1. And for every z, we have to consider this equation because this one is independent of the z. So here eventually it will make a vertical cylinder like that, the infinite. And from here in whole line, the collection of these lines will be the surface of this equation. Now for this one, for every x, for each x, it will make a circle in the y-z plane so that this one is a cylinder in x direction. You can sketch it yourself. A quadric surface is the graph of a second-degree equation in 3 variables, x, y, and z. That means that quadric surface is the graph of second-degree equation. Second-degree equation will involve a constant term x, y, z, and second-order terms x squared, y squared, z squared, and xy, yz, and zx is a general equation. But if you apply translation and rotation, then we can write the equation of quadratic surfaces in these standard forms, you can reach either this one or that one. So we call these equations the standard form of a quadratic surface. The trace of a surface in R3 is the graph in R2 obtained by allowing one of the variables to be a specific value, specific number. For example, if we choose x equal a, then x equal a is a plane, so that from given surface, if you cut the surface by using a plane, then you'll see a curve as the intersection. That is the trace. So by using traces, you can sketch the 3D surfaces. Use the traces to sketch x squared plus y squared over 9 plus z squared over 4 equals 1. Okay, for that one, we may try to get traces along with, for example, z variable. Once z equals 0, then the equation becomes x squared plus y squared over 9 equals 1, which is an ellipse. And now once z equals 1 or now minus 1, then that will become quarter, so that x squared plus y squared over 9, quarter is moved to the other side, which makes the right side 3 over 4. Now how about z equal 1, okay, 2 or minus 2? Then now that will become 1, so that it will be 0, x squared plus y squared over 9 equal 0. Let's try to visualize the traces. Okay, in the 3D coordinates, that is x direction, this is y direction, that is z direction. Here, when z equals 0, it means is the plane in xy plane. In xy plane, in y direction is 3, and in x direction is 1, and it is an ellipse passing these points. Okay, so we can get here an ellipse like that in on the xy plane. Once z is moving 1 or minus 1, then the same kind of similar ellipse, but now it's smaller, so that we have smaller ellipse here. And once z equal 2 or minus 2, then that means a point. For various z values, if you make this ellipse a flat ellipse, then if you collect them, then you may get a shape like that. It's passing like that, and bottom also same. So the final result will be on ellipsoid. Right? And here in x direction is 1, in y direction 3, and the z direction must be 2 here, right? Use the traces to sketch z equal 4x squared plus y squared. For this one, if you use z as a constant, then it may be easier. Rather than that, let's try to see the traces along with y values changing. Okay, if y equals 0, then on the x and z plane, we have an equation of parabola z equal 4x squared. Once y equal 1 or minus 1, then z equal 4x squared plus 1. Okay, let's visualize these traces. There's x direction, this is y direction, this is z direction. Y equals 0 means the xz plane. On the xz plane, we have a parabola z equal 4x squared. So we have here a parabola. And now, once y equal 1, then the vertex must be here, this position. Once it is 1, then the height is again 1. So again, the same shape of parabola must be here. So along y direction, the vertex is making a curve, quadratic curve, and like that. So if you collect these traces in y positive direction and negative y direction, then again coming up that way. So eventually all the collection of these traces will make a paraboloid. And because we chose y so that it's not easy to draw the final figure. However, for example, if you start with a z constant, then maybe easier. Start with a z equals 0, then the equation becomes 4x squared plus y squared equal 0, which is a circle on the xy plane, but in fact there must be 0. In fact, ellipse, but because 0 must be a point. If z equal 1, then that is now 4x squared plus y squared equal 1, and so on. So here in the 3D coordinates, and x direction, y direction, and z direction, in the beginning on the xy plane is a point, and once it's coming up, then it's on ellipse. Now once z is 2, then the right side must be 2, so it is a little bit larger, like that. And again, once 3 and 4, then becoming larger, 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 so that each cross-section, horizontal cross-section, make an ellipse, but larger, larger, larger. So if you collect this ellipse, then you can see the final ellipsoid. Sometimes you need try to get traces from 2 different directions. In this case, along with y. In the case, along with z, we try to make traces. In this case, you can understand the surface better. Okay, that's the end of the section. Thank you.